Hi, this is Rob Pearlman with collectSPACE.com. Can you hear me?
Loud and clear.
Hey. Good to talk to you, Robert.
Great, thanks. It's great to see you all underwater here. To start off with Shannon, can you describe briefly how NEEMO 15 differs from previous NEEMO expeditions, specifically in regards to simulating an asteroid mission?
Sure. In previous missions, the emphasis of NEEMO was to look at habitability and doing different types of science underwater, things such as telemedicine. On this one, we're specifically looking at how to collect science on an asteroid. So this is the first one that we've done asteroid-type experiments, if you will, at a NEEMO. So we're sort of moving forward, looking ahead to see how we can use NEEMO to progress our understanding of what we need to understand and to build once we start out into the solar system.
And staying with you for a moment, since you recently, not too long ago, came back from the space station, how does life on Aquarius compare to life on the space station?
In a lot of ways, it's very similar to life on station. We have a pretty rigid schedule that we have to keep. We're living in small quarters, and there's 6 of us here. So in that respect, it's very similar to station. Of course, the station is actually a lot bigger than the Aquarius habitat, so we have more room on station and no gravity up there, which gives it a different twist.
For Steve Squyres, I've been reading your blog, and flying jetpacks on the ocean floor while conducting a simulated asteroid mission might just be the most awesome thing I've ever heard. So, but the awesomeness of the activity aside, how do you expect a future real mission to an asteroid to resemble what you're doing now, what you and your crewmates are doing now on the ocean floor? How close will it be?
Well, that's exactly what we're trying to learn. If you sit down and imagine the kinds of techniques that you might use for moving around on an asteroid, for anchoring to an asteroid, for doing work on an asteroid, there are a lot of possibilities. You know, I talked in my blog yesterday about jetpacks and booms, but you can use translation lines or wires strung out across the surface. You can use small spacecraft to fly people around. You can use some kind of big crane. We're actually trying out all of those. And I think what's going to emerge from this is a much better understanding of which are the right techniques to use. And I don't want to guess just now what the answer is going to be, because we're only partway through this. I sort of got my likes and dislikes so far. But I think in the end, once the data are all analyzed, there's going to be a pretty clear picture emerge of what's the best way to do business in this kind of environment.
And since you are familiar with working with a time delay, given the remotely controlling Mars rovers, I think you're doing some communication delays, simulated communication delays with this mission. So how is that an easier or harder challenge for a human crew to compensate than when trying to drive a rover on Mars?
Oh, I think when you've got a human crew all working together, you're going to have a degree of autonomy that you can never build into a robotic spacecraft. We try to make our robotic spacecraft as smart and capable as we can, but they're never going to match what a human crew can do. And so if you have a human crew that's a long distance from Earth, they can't interact in real time with the Earth, they are going to have a degree of an ability to work together and to solve problems that's going to make them much more effective than any robot could be.
Well, great. That's my time. Thanks, everyone.
Thank you, Robert.